This is a short introduction of the Higher Order Programming Environment, or HOPE. With HOPE, we use both specialized and general-purpose autonomous computing units, called receptors, to compose rich data transformations and visualizations. All data is semantic. It carries both value and structural meaning. Receptors, like cells, absorb specific semantic data, perform computations on the data, and release the computational results as semantic data into the inter-receptor space, where other receptors process the new semantic data. Membranes define bidirectional permeability within receptor groups to control data flow and create computational islands. The demo you are about to see illustrates some of these concepts. We will utilize several different receptors to extract specific information from a website and to interact with the website's information in different ways than originally intended. The website we'll be working with is NASA's Astronomy Post of the Day, APOD website. Note that I will not be showing how to create the semantic types. These have all been created beforehand. For example, we can see how one such semantic type, called web image, is a composition of both an image semantic type and a URL. If we look at what the image semantic type looks like, we see that it has a value. This is the system image class in the .NET framework. It has a title and a description. So a web image is actually a hierarchy of several other semantic types. So let's get started. First, we will select the APOD receptor and add it to the surface. This receptor will query the astronomy post for a specific date, but it depends on a general-purpose HTML scraper to extract the HTML. Once it gets the HTML, it extracts some content, such as the image, the title, and description, and issues this as a web image semantic instance. Let's add a signal creator receptor so that we can feed dates to the APOD receptor. Now this is a general purpose receptor in the sense that we can select the semantic type that we want to create, and the UI generates the entry fields dynamically for us. Now it doesn't really know that a date could be selected with a date control, so it just gives us text boxes for the different value types within the date semantic type. So I'm going to put in Valentine's Day of 2014, and we'll click on Create. Now notice here we have a connection now between the signal creator and the APOD receptor, and that the semantic type that is being conveyed from the signal creator receptor to the APOD receptor, that semantic type is date, because that is, after all, what we selected here in this dialog, and APOD is receptive to date semantic types. Now let's add the web page scraper receptor, and you're going to see something interesting. You'll notice how there's this interaction now between APOD and the web scraper. What's happening here is that APOD, once it gets the scraped HTML, it's actually generating a web image semantic type instance. That web image, as we noted over here, contains a URL, and because receptors can also respond to subtypes within a semantic type instance, the web page scraper is actually responding to the URL in the web image instance as well. We don't really want this behavior, so we're going to create a membrane around the web page scraper, and we're going to configure it so that we are permeable only to the URL as a root semantic type, not as a subtype. And we also have an outbound permeability for the web page image. I'm sorry, for the web page HTML. And now we have stopped that feedback loop. Now let's get to the fun part. We're going to add an image viewer. And that popped up a separate viewing window. Now that my screen space is limited here in this video, so we're going to have to switch back and forth between things. We'll put a membrane around the image viewer as well to constrict its data transfer of semantic types as well. So what we're interested in here is a web image, and there we go. Now you can see over here we have this beautiful picture. Now let's quickly add a couple other receptors. One is going to be a text display receptor for the description. So I'll add that, and we want to restrict it specifically to the description semantic type instance. And then I'm going to do something interesting. I'm going to add a web page viewer receptor. And what I want to do here is take just the title. So we're going to say we're receptive permeable in for the title. And I'm going to configure this receptor for doing a Google search on the title itself. So we're going to add this little URL with this token. It's called search, which takes the title, replaces the text in the title with this token, and performs a Google search. So now let's just re-trigger this whole thing again. And move this out of the way. We can see the semantic type instances being moved about to the different receptors. And now here is the result. We have these three different tabs. We can reorganize this a little bit. So let's move the text over here. And let's move the image down below the text. And here's our Google search, where we can now see things that relate to light from the heart. We can look at, for example, another date. There go the different semantic type instances, and here's the result. So, in conclusion, this really is just a teaser of how you can use Hope to create dynamic and rich applications. And I encourage you to visit the higherorderprogramming.com website for more examples, articles, and videos. Thank you for watching.